All right, so here's 5.5 properties of logarithms. So, log base 3 of 3 to the 76. Okay, so how are we gonna do this? What are we gonna do? Well, there's 3 properties of logs, and maybe I think I'll write them up for you. And yeah, let me write that here. So 3 log properties. This whole section is based on the 3 big rules of logs. So number 1, log base b of x times y is log base b of x plus log base b of y. See how multiplying becomes adding there for 2 logs? And then property 2, log base b of x over y is log base b of x minus log base b of y. And property 3, log base b of x to a power. That power can come down like that. So there's the 3 big log properties. I'm going to write those on the board as well, just so we have them. We'll use them for the whole section. We could use them over and over again. Log base b of y. Okay, so so you got to remember all you can put them on your 3x5 card for the third exam, but let me help you kind of recognize them. Notice what's not changing first off. They all have b as a base, don't they? That's not going anywhere. That's not changing at all. They all have log b, 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 right? The b is just glued to the log. We're not messing with that at all. The only thing that's changing is the other stuff that comes after it. And that is what? Multiplying becomes adding, dividing becomes subtraction, and powers go to the front like that. Do you know what logs are doing? Let me say it to you this way. Logs, do you remember the order of operations? What's the order of operations? Parentheses, exponents, multiplying and dividing. Remember the old saying, please excuse my dear Aunt Sally? Or PEMDAS, or however people say it. Right? See, I put the M and the D on the same line, the A and the S on the same line. That's because they're the same level. So this is multiplying and dividing. This is adding and subtracting. And this is powers, like 2 to the 3rd and stuff. Well, if you think about it, what logs are doing is bringing everybody down a level in the hierarchy. And the hierarchy is based upon, like, think about when you were a kid. What's the first thing you ever learned in math? Adding. Weren't those the days, right? Just adding. Math was easy. Math didn't seem bad back then. And then I remember 4th grade when I had to learn multiplying. We had to go up to Mrs. Unmack's desk and tell her our times tables. That was very scary. So anyway, so you start out with adding, subtracting, get a little older, you do multiplying and then dividing, right? Well, that's exactly how the order of operations are. Adding, subtracting is first. Then you get a little older, multiplying, dividing. Powers come later, right? Well, those are in a hierarchy for a couple of reasons. Let me connect all that for you. They're in a hierarchy by repetition. What do I mean? If I go 5 times 3, isn't that 5 plus 5 plus 5? Isn't that what it means? Is it multiplying, repeated adding? Isn't that true? Is it multiplying, repeated adding? And what's powers? Repeated multiplying. What's 2 to the 3rd power? 2 times 2 times 2, isn't it? Do you see that? You ever thought about that? You ever stayed up late at night and thought, oh, the level operations is repetition to the lower level? No, that's what weird math teachers do, huh? But that's the truth. That's how they're related. Powers are repeated multiplying. 2 to the 3rd power means multiply 3 times. And multiplying is repeated adding. 5 times 3 is 5 added 3 times. And dividing, by the way, is also repeated subtraction. How so? 10 divided by 2 is 5, isn't it? That's how many times you can subtract 2. Repeatedly out of 10, isn't it? So dividing is repeated subtraction. Multiplying is repeated adding, and powers are repeated multiplying. So they're in a hierarchy because they repeat the lower operation. They're more powerful, aren't they? Right? And when you're a kid and you're adding 5 and 5 and 5, later you learn you can just go 5 times 3 and memorize it's 15, and you've added really quickly. It's more powerful, isn't it? So that's what the hierarchy is. What does that have to do with logs? Logs are playing into that hierarchy. They're basically bringing everybody down a level. Because remember what they are? They're the opposites of power functions. So instead of raising everybody up, they bring everybody down a level. What am I talking about? Look right here. Multiplying becomes adding. That went from multiplying down to adding, brought it down a level. Dividing becomes subtraction. Dividing becomes subtraction. Brought it down. And powers becomes times. Powers come down to multiplying, don't they? Do you see what logs are doing? So if you get that idea, you got it. Because you already know the order of operations. I'm trying to make some connections for you, but it's easier to remember. Logs are just bringing everybody down a level. All those rules are just bringing everybody down a level. That's what they're doing. That's what all those rules are saying. And multiplying is tied with adding because they both make things bigger, don't they? Multiplying, adding, make them bigger. Dividing and subtracting make things smaller. So, of course, they go together. Last thing to help you remember, how do you know whether it's like 1 log? Why is it going 1 log to 2? See how that is? See how it's going 1 log here, but then there's 2 over here, and 1 log here, and there's 2. Property 3 is just 1 log to 1 log, so I'm not talking about him right now. Properties 1 and 2, though, go 1 log to 2, 1 log to 2. How do you keep that straight? Basically, it's like the old saying. Remember that old saying that says, many hands make the job lighter? Like that, you know, like more people working on something. You know, I helped a friend move a couple months ago, and you know, I hate to brag, but I lifted a 700-pound table. You know, me and like 6 other guys, right? So it obviously made it doable because there was a whole bunch of us, right? That's the idea with the logs. Notice the easier operation is always with the 2 logs, adding. For 2 logs, it's just adding. For 1 log, it's harder, it's times. You see that connection? I'll help you remember it. For 1 log, it's the harder operation. It's a harder job for 1 person. It's easier for 2, which becomes adding. Same thing here. Dividing, that's a higher level operation. You learn that later. It's higher in the hierarchy. Just becomes simple subtraction. For 2 logs, becomes easier for 2. All right, so there we go. There's all the connections for all those properties. Let's do this problem. All right, they want me to use properties. What can I do with that power? He just comes down to the front, doesn't he? 76 times log base 3 of 3. Good so far? Powers come down to multiplying. That's property 3. Powers just come down to the front. Okay, great. So what? Well, now, do we know how to figure this out on our calculator? Yeah. If there's no x's, if it's just numbers, we can do it on a calculator. How do you do it on your calculator? The top goes top and the bottom goes bottom. Just make it 2 logs, remember? The top goes top and the bottom goes bottom. Of course, they're the same thing, which is what? We don't need a calculator to tell us what that is. Log 3 over log 3 is 1. Yeah, so this is 76 times 1. It's 76. Done. Good? That makes sense there? So 2 rules that we've learned. How to do a log, which is top goes top, bottom goes bottom, so that's 1. And then 76 times 1 is 76 because that power came down to the front. What you do? Yeah, log base A of R is R. Yeah, they're basically saying these cancel, which is what we see happen in the end, how those cancel. When these guys match, that's why they're putting A and A. When they're the same, it just cancels and it's R. Yeah, I'm giving more reasons, but yeah, that's true. Okay, so natural log of e to the 18. All right, what have we learned by the properties? What can I do with that power? What can I do with that 18? Just comes down to the front, huh? Remember, powers can come to the front and just become multiplying. Powers become multiplying. And what do you... Is it good so far? What is the ln of e? Remember, logs and powers are opposites, right? So, what... There's another e there. Let me just say it that way. There's another e there. Well, how do I know? Well, because there's always a lower down number. So that red e is just on the level. That's not the base. There's another e that's the base. Okay, so what? Well, that means this is high, the top goes top, the bottom goes bottom. That's 1. Isn't it? So it's 18 times 1, it's 18. Everybody with me on that? ln means log base e, doesn't it? ln means there's a hidden, invisible base of e. You good with that? So it's just 18. All right. So what have we learned about logarithms? Like if somebody was to stop you on the street, didn't I talk about this? If somebody would have stopped me on the street and said, what is a log? I would have had no idea. But I hope you guys have an idea now. If somebody would have stopped you on the street and say, what is a logarithm? You're in one of those high-level math classes. What is a logarithm? What is it? What would you say? Yeah, you weirdo. Just get out of here. So what would be a truthful answer to that question? We'll set aside all normal social conventions and pretend it's okay to ask such weird questions to random strangers on the street. Logs are inverses of powers. Is that coming through? I don't know if I've brought that through clear enough for you. You really want a central focus on that because that'll help in so many situations. Logs are inverse powers. Logs are inverse powers. That's what they are. They're inverse powers. Yeah?
But what about roots? Like square roots and cube roots and things like that?
Right. So like a square root of, how would you solve square root of x equals 7, for example? That's a good question. Let's talk about that. How would you solve that for x? How would you turn that into normal x? How do you do square root of x equals 7? What do you do? You would 2 power both sides, wouldn't you? Square it, that's called. Not square root it. When you say root, you mean the root symbol. You'd square it, right? Right? Because that would cancel, right? 2 powers and roots are opposites. And you get 49, right? What if you had a third root of x is 4 or whatever? What would you do? Third power, both sides. Because again, they're opposites. Roots and powers are opposites. Well, that's exactly what logs and powers are like. They're opposites. Get the idea? So if I have a log I want to get rid of, I do a power. If I have a power I want to get rid of, I do a log. They're opposites of each other. So my point is, these guys just cancel. The answer's 3. They're opposites. Does that make sense? Because that log is being raised to a power. Powers and logs are opposites. They're completely opposites. And so they just cancel out. All right. So log base 12 of 3 plus log base 12 of 4. They want me to use properties of logs. What am I going to do? Is there a way that I can put those 2 logs into 1? Can I make those 2 logs 1? Look at property number 1. Adding for 2 logs is equal to multiplying inside of 1 log. Oh. And the base doesn't change. So just keep the base 12. We're not doing anything with that. And then instead of 3 plus 4, it's 3 times. Remember, harder job for 1 log, easier for 2. Multiplying for 1 log, it's a higher operation than adding. Adding easier for 2, right? Easier job for 2 people, harder job for 1 person. Harder job for 1 log, multiplying for 1 log, simply adding for 2. Is that good? And then what's that? That's log base 12 of 12. Yeah, and how do you figure that out? The high goes, the top goes top, the bottom goes bottom. That's just 1. I don't even need a calculator. I know that's 1, huh? Does that make sense? Questions? You all good? Give you a little time. Make sure it's making sense for you. So try that one. Put those things into 1 log. Combine it into 1 log. It's subtraction for 2 logs. So make that into 1 log. So notice how the bases are the same. They're always going to make the bases the same. Well, almost. It'll be like 1. So subtraction for 2 logs is going to become Division, right? Division, a harder job for 1 log, 30 over 6. That good so far? Dividing is a higher operation than subtraction. See the analogy I'm giving you? It's a harder job for 1 log, easier for 2. And then what is 30 over 6? So what does that equal? The top goes top, the bottom goes bottom. It's another 1. If in doubt, guess at 1. Seems to work. Questions on that? Is that good? How we did those properties? Is that making sense? Can't get much from you guys today. You guys give me the poker face. I need to know a yes or a no. Like, I need more of those. Let me know. That way I know whether to speed up or. Let's try this one. Yeah, log base 4 7 times log base 7 of 64. Yeah, try that one. That's a trick. Give that a try. You can use your calculator. The answer should be 3. Does it look like 3? No.
Is there going to be a rule where you end up, because it's 7 and 4?
Yeah, there is a rule. But you know what? And I'll give you the rule in a minute. But really, you don't even have to know the rule. You could just remember what we learned about the top goes top, the bottom goes bottom. Top goes top, bottom goes bottom. You could just do that, right? Remember how we learned about when you have a log, you can let the top part go top and the bottom part go bottom. Make it into 2 logs, right? By the way, that's not one of these properties. That's a separate rule we learned previously. Hope I'm not confused. That's not one of our 3 properties. All right, let me just write that one up, though. That's just, let's just call that a 4th property or a 0 property because it was before the 1, 2, and the 3. So the 0th property of logs, and that is the log base b of a. The top goes top, the bottom, you can make it 2 logs. That's not one of the 3 properties. That was a previous property that we did in the last couple sections. And that is the top goes top and the bottom goes bottom. You can always do that if you want to. That's always okay to do. And if you do that, do you see what happens? See what these guys do? Those cross cancel, huh? Log 7, cross cancel. So just use your calculator. Log 64 divided by log 4 should be 3.
Even if we already divided it into a calculator and did it separately.
Yeah, if you just did the whole thing and didn't cancel log 7s, that's fine too.
Get the same answer.
Same answer. Good on all that? So that makes sense. You're getting all these properties out. So we got the 3 new properties with the whole bring it down a level, and then we have that old property. You can always make 1 log into 2. The top goes top, the bottom goes bottom. All is well. 3 to log base 3 of 1 minus log base 3 of 4. That's weird. It's all up there in the power zone. Any ideas on the answer? I mean, you could just type the whole thing in your calculator. It's all just numbers. There's no X's anywhere. Right?
It says don't use your calculator.
Oh, well, it won't know. Yeah, no, you can use calculator on the test. Yeah.
And the calculator, how would you type it up?
Yeah, it's a little tricky though, huh? It's not these. All that stuff's got to be up in the power zone, which means you need to parenthesize it. Whenever you put more than one thing in a zone, numerator, denominator, or power zone, if it's more than one thing, you got to parenthesize it. Otherwise, the calculator won't know it's all up in the power zone. So yeah, if you want to type it in like that with that all up in the power zone, the answer should come out 0.25, right? 1.4. Now I'll show you some properties, but it's probably easier just to type it in. Did you forget the minus log base 3? You got to do the whole thing. Yeah, it's got to be the whole thing. All right, so now it is 1/4. Here's the reason why, but it's kind of some fancy properties. Do you remember the rule? If you have, let's say, x to the 5th over x to the 2nd, Do you remember the rules from algebra of powers? What does that equal? X to the third, right? What's the rule for powers? We minus them. When we're dividing, we minus. Remember that rule from algebra? Well, in other words, I could write that 3 as 5 minus 2, couldn't I? It's just another way of writing 3. In other words, this minus this, right? Well, that means if I started with this, I could trace it back to that, couldn't I? That's what they're giving me here, you see? This is like the x. This is a first power, like the 5. This is another power, like the 2. So that means to the top one over to the bottom one. There's words in the way. Let me get those words out of the way. Do you see that? I know that's probably kind of tricky. Do you see that's the same thing? Right? Because if you have the same base divided, you can subtract the powers. See how that's the same? I just ran that property backwards. Do you see that? Everybody see that this is that? It's kind of tricky to see that, right? Because if you have the same bases divided, you can make that subtraction of powers. So same bases divided, that's subtraction of powers, isn't it? Now, okay, so what? Well, then these cancel. Remember, powers and logs cancel. These cancel. It's 1/4. Boom, done. So there's how you could do it with just observing properties. This making sense? See how this forces you to really, really, really know those algebra rules? Forwards and backwards and divisions of powers and subtractions and all those. That's what calculus is all about. That's why people have trouble in calculus. It's algebra. I mean, this is really just an algebra rule. Really, this is something you learned in algebra. But that's having to know it super well, huh? Forward and backwards and recognizing it out of context. That's why people have trouble in calculus, because it's that even more. They push that even more. You really have to be a master of algebra. Just forward and backwards in every which way. Know those rules like the back of your hand. And you can do it. It just takes practice.
So if you, instead of turning it into a fraction, if you did log basically 1/4, like rule 3 or whatever, and then the 3 and then the log 3 and x.
Oh, yeah.
would cancel, right?
Totally. You know what? I like the way you're saying that. That's a better way. I'm kind of doing something that's too hard. Yeah, I like that. I just didn't even see it that way. Yeah, that's way better, huh? I think that's what they really wanted us to do. I don't know. I just saw this other weird rule. But yeah, you're totally right. Yeah, I should have been thinking that way. These are just subtraction, right? Subtraction of 2 logs. What does property 2 say? Subtraction of 2 logs is dividing. Yeah, you're totally right. I did something harder. Yeah, they just want you to make this 1/4 right there, right? Subtraction, 2 logs, make it 1 log divided, and then these guys cancel. And it's 1/4. I mean, the answer's right either way, but that's better. That's probably what they want you to do. Rather than that hard observation I was making about that other stuff. Is that good? Thank you. Better. Log base 6 of 1296x. All right, so they want me to write it as a sum or difference of logs. So they want me to take this 1 log and make it 2 logs added or subtracted. That's what they're saying. Write it as a sum or difference, adding or subtracting. So take that 1 log and make it 2. How can I do that? What's happening what's in the middle between 1296 and x? It's nothing, which means multiply, huh? Yeah, it's times. So multiplying for 1 log, property number 1, multiplying for 1 log becomes adding, huh? And so it's going to be adding, and you keep the base the same for both. We don't change that. That never changes. That 6 is just glued to the G there. 1296 and the x, right? There it is. Is that good? 1 log with the arguments multiplied becomes 2 logs added. Right? Easier job for 2 logs, right? Adding, easier job for 2 people. Harder job for 1 log, multiplying for 1 log. Log base 6 of z to the 9th. So, what can we do with that 9 up there in the power zone? Yeah, so that's property 3, right? That just is 1 log to 1 log. Powers just drop down to the front. So 9 log base 6 of z, and that's all they want on that one. Just bring that 9 down. That good? So property 3, powers come down to the front on that. Questions on that? I'm going to see. So natural log x to the 13th square root of 3 minus x. Okay, so same thing. Write as a sum or difference. So can you take that and can you break that into 2 logs? So go ahead, give that a try. Break that into 2 logs. And natural log is the same rules as the other logs, right? Natural log just means base e. It's just a special kind of log. Same rules. All the same log rules apply for natural log as they do for any log. So break that into 2. That's x to the 13th times the square root. So it's multiplied. Yeah, base is e, yeah, but you don't have to write it. The ln means invisible base e, but no need to write it. Break that into 2. So that would become ln of x to the 13th plus ln of root of 3 minus x. Good so far? How we doing? So a harder job for 1 log, multiplying, becomes an easier job for 2, adding. Now, there's one more thing we can do. Well, there's a couple things. What do we do with that 13? 13 comes on down. Because powers make factors. Factors means things multiplied. So they're saying take your powers and put them in the front as a multiplied. That's what they're saying. Okay. Bless you. Now, what can I do with that square root? Square root of 3 minus x. Did you guys know, do you remember that means 3 minus x to some power? Do you remember that square root means a power? Remember that from algebra? So here we are hitting on another old algebra rule. Square root means what power? Half. Not 2, but half. Remember that fractional powers are square roots. Or roots. Remember that from algebra? That, let me just write the rule up here. Here's the old rule from algebra. That anything to the a over b, fractional power, the b swings around and ends up in the hook. Do you remember that old rule? Fraction powers mean roots. That's what they mean. Did you catch that from algebra? Probably not completely well. That's why the pre-calc and calc can really solidify that. Fraction powers, the denominator swings into the hook. So that means anytime you see what's in the hook, when I write this square root and there's nothing in the hook there, what's really invisibly there? 2. Yeah, it's the only invisible 2 I know of in math. There's really an invisible 2. That's why we call it a square root. Square means 2, huh? So there's really a 2 there, and there's no power on this 3 minus x, so there's really an invisible 1. That's where the 2 swings back, and that's why we get the half. Does that make sense on that? If they gave me other numbers, if they said, hey, this is a 7, and this guy here is a 4, then that would be 4 7s, wouldn't it? You with me? But they didn't. They gave me 2 invisible numbers. This is an understood 2, that's an understood 1, so it's a half power. So what? Well, that means this is 3 minus x to the half power. So you're going to want to remember that they're going to test that like a few times. You're remembering of a square root being a half power. So that square root's a half power, and what do we do with powers? Down to the front. So then the final answer is 13 ln x plus a half ln 3 minus x. There we go.
Every time you see a square root, that's the problem, so we just remember to put...
Oftentimes. Not every time, not every situation, but be aware of it. It'll come up a lot. When you see square roots, that's a half power. Yeah, it always, It always means a half power. It's just not always useful to show it, but it often is. Is that good on that? Square roots are half powers. Okay. All right, so log base 3 of x to the 14th over x minus 5. All right, try that one. Break that into 2 logs, right? So break that into 2 logs. Are we good so far? Hey, do I have to have parentheses on that x minus 5? You do, because if you don't put the parentheses, then only the x is, that. If you write it this way, that would mean it's just log base 3 of x, and the 5 is outside. It's not plugged into the toaster. And that's not correct, because from the beginning, the whole x minus 5 was plugged into the log. So the whole x minus 5 must continue to be plugged into the log. Like that. Last step, bring that 14 down, huh? So 14 log base 3 of x minus log base 3 of x minus 5. All done. Oh yeah, you don't have to do anything with it. They're telling it to you because they don't want the denominator to be 0. But we don't have to do anything with it. Yeah. Is that good? All we have to do is do the properties. Hey, can I do this? You can tell by my tone the answer is no. Can I break? I see this a lot, though. Can I break that into 2? No, I mean, you can tell by my tone the answer is no. But why not? Isn't that the property? Isn't that what property 2 says? Subtraction? Division. Yeah, property 2 says subtraction is division. It says subtraction for 2 logs is division for 1 log. This is not subtraction for 2 logs. This is subtraction within 1 log. That's a different animal, huh? So it's not property 2. Well, then other people often will say to me over the years, they'll go, well, sir, I'm just distributing. I'm not doing property 2. I see what you're saying, but I'm just distributing. It's just distribution. That one's more tempting for you, huh? It's not multiplication. Why is that? Yes, it's not really important, especially if you're going to go to calculus. That is not multiplication. Super important that you know that. Remember, that's why I'm always doing the toaster talk. This does not mean log 3 times this and times this. No, it's like a function. It's like f of x minus 5. Right? Log is a function. All these things are functions. Trig, sine, cosine, tangent, e, all these things are functions. They're plugged in. It's not, those parentheses don't mean times. Those parentheses mean plug into the toaster. Right? That's log base 3 of x minus 5, not times x minus 5. Really important. That's what will keep you from messing up all the rules in calculus. People that don't get that difference, it looks like spaghetti, and they are soon out the door in a couple of weeks of calculus. So you don't want to be that way. You want to know the difference between a function and multiplication. Do you see that difference? Those parentheses, it's like a function. It's not times. So that's why we can't do all this stuff. Sometimes it's important to know what not to do. So let's try that one. Same kind of thing. Break it into a few logs there. Yeah. Yeah. Do you see the different pieces? How many pieces do we have inside that log? X alone, x plus 4, and x plus 3. 3 pieces, right? 3 separate things multiplied and divided, right? So that'll be 3 different things added and subtracted, right? 3 different logs added and subtracted. question, yeah.
Does it matter that it's in brackets, not parentheses?
Good question. No, yeah, brackets and parentheses are the same exact meaning, just different style. So it's totally the same. Good question. So we're going too quick. So break it into 3 separate logs. Yeah.
Does the part where it says like x is greater than 0, does it even really matter for your answer?
No, you don't have to do anything with that. Yeah, it's just ignore these little things they're putting over here. They're only doing it because that way it doesn't make the inside of any log 0, but we don't have to do anything with it. Just don't let that throw you off. So it's going to be this. And that. Is that good so far? I'm almost done. One more step. Just got to bring that 5 down. Is that good to there? Does everybody see? Why did I make it adding for the first 2 and then subtracting for the third one? Because it's on the bottom. It's divided. The third one's divided. Divided becomes subtraction, huh? The first 2 are times. That's adding. Everybody seeing that? So the stuff on the top, the numerator, those are multiplying, so it becomes adding. Stuff on the bottom, that's dividing. That becomes subtraction. 3 separate logs. Is that good? Last step, just bring that 5 down. So 5 log x plus 3. Bring these guys down. There we go. Is that good? Questions on that one? Yeah.
Could you maybe distribute the x to the x plus 4? Or no?
Oh, yeah, you could. I mean, that's certainly valid. The only reason I don't, I mean, you're totally right, make it x squared plus 4x. That's totally valid. The only reason I don't is just because that's just simply not what that's something true, but not the direction they want me to go. They're saying, write it as a bunch of logs. So I'm not really interested in doing stuff within a log. I'm moving in the direction of several logs. Yeah. So I just don't go that way, even though it's true.
I get what you're saying.
Is that good on that one? Other questions? So we're just breaking these into several logs. Stuff in the top is always added. Stuff in the bottom is always subtracted because denominators divide. Dividing becomes subtraction. Multiplying is adding. Dividing is subtraction. All right, and powers go and uglier. All right, what do you do with that big half power up there? Down to the front, huh? Powers go to the front. Move that to the front. Hey, what should you do with x squared minus x minus 2? Yeah, factor that. Do a couple parentheses. Why am I even thinking to do that? Well, because if I get a couple things multiplied, I can break those into 2 logs added, huh? Multiplying becomes added. The one on the bottom was divided, now becomes subtracted. A third log subtracted. And all that. So how's that fact? How do you get 2, 1 and 2? And how do the signs go? The sign in the middle, remember it's always the sign in the middle when you're factoring. The sign in the middle that tells you where to put the signs. The sign in the middle is negative, so the bigger one is negative. Minus 2 plus 1. Is that good either order? Right, the sign in the middle always goes on the bigger number. Do you remember that from factoring, that rule? So go ahead and break those into 3 logs. Like, we don't have to do anything with the x greater than 2. That's just them telling us how the thing will not have a negative inside of a log.
So
Yeah, Amy.
goes on each,
What's that?
the 1/2 that we put.
It is. Very good. Yes. The half, exactly. The half is going to end up on all 3 pieces. Why? Because the half power was on everybody, wasn't it? So when the half power goes to the front, it'll be the front of everybody. Good point. And the last step, that 5 will come to the front and be 5 halves. Whoops, I forgot the ln in the middle. What am I doing? I lost my ln. And there we go. Is that okay? You'll see what happened there? So yeah, that's a good question. Amy was saying that half power is on all of them, huh? So the half ends up in the front of all 3 logs, doesn't it? Whereas like the last problem, see how I had this 5 power was only on the x plus 3, so we only ended up in the front of the x plus 3. Or this one here, or was it? The square root was only on the 3 minus x, so the half ended up only in front of the 3 minus x. Everybody see the difference on that? So this half power is on everybody, goes in the front of everybody. Yeah?
Why not multiply the 1/2 and 5 for that last natural log?
Say that again?
Why not multiply the 5 and the 1/2 on the last natural log, making it 2.5 natural log?
Oh, make it a decimal instead of a fraction. 5 halves is that. A half times 5 is 5 halves. I did multiply them. Yeah, either decimal or fraction's fine. Either way. On that. Good. Other questions on that? Is that good? All right, so try that one. We'll go quick. Again, you don't have to do anything with the x greater than 5. Who cares? Whatever. That's just making the denominator not be 0. So anyway, just take it from there, break it into a bunch of logs, add and subtract it, bring power to the front. You got square root. You know what that means? Half power, right? Bring it to the front. So it becomes ln 3x plus ln square root of 1 plus 8x minus ln x minus 5 to the 10th. Good first step. The ones on the top are added. The one on the bottom is subtracted because it's divided. And what do you do with that square root? Now it's a half power, so we talked about square root to a half power, comes to the front, and the 10 comes to the front. So it'd be ln of 3x plus a half ln of 1 plus 8x minus 10 ln of x minus 5. Like that. There we go. Now, I wonder, I'm not sure, I'm sincerely not sure, if they want me to separate that 3 and that x, into 2 logs, because those are 2 things multiplied.
They do, yeah.
They do? Like they won't take it the other way?
They won't take it, yeah. It actually corrects you, it tells you what you
Oh, okay, so it wants you to replace this as those 2, because those are times, they're being pretty picky. Those are multiplied, so okay, I'll separate it. Is that good? I didn't realize it'd be quite that picky. So take it now? All right. You all good? So 7 log base 5u plus 8 log base 5v. So now we're going to say, hey, make it a single log. Put it together into 1 log. So now we're just going to run the properties backwards. Adding for 2 logs, adding for 2 logs. Notice the bases match. Oh, it's 5, not 15. What am I doing? So log base 5. The 7 goes up to the power. The 8 goes up to the power. And you times these guys together. Because adding, an easy job for 2 logs, is times harder for 1 log. Good enough? Should run the properties backwards? Properties getting easier. See how that works? Question? Yeah.
Is the U7 and B8, is that the next one at 4? Or is it just like? Never mind, I see what you're saying.
Yeah, it's like that. Is that good? Like this? It's all together like that. That all good? Questions I can answer? So we just put them together, right? Adding becomes multiply, and numbers in the front go back to the power zone, don't they? We're just running the properties backwards now. Now we're just going backwards. Same property. Ooh, let's see. Let's try it. So log base 3 root x minus log base 3x to the 6th. All right, you've got the answer looking at you there. See if you can get to it. So put those two together. Subtraction for two logs becomes what? Put it together, and then use some power rules from algebra. That's what's happened. Oh, they got that minus 11 halves. Think about powers. All right, so what? That's square root of x. What do we do with that thing? That's our half power, right? Which comes to the front. Wait, do I want to do that? No, I don't want to do that. I mean, that's true, but that's not helpful. You first want to put them together. So let's put them together. So log base 3, it's going to be root x over x to the 6. Everybody good so far? I mean, that other thing I was showing is true, but that's going the wrong direction. I want to put them together, not separate them, right? So put them together like that. So far, so good. Subtraction becomes dividing. Now, is there some kind of way, it's all about algebra at this point. How do I take root x over x to the 6 and make that x to a single power? Do you remember that from algebra? It's the kind of thing you do in calculus all the time. They just assume you know how this becomes that. Because it is a rule that you did learn in algebra, but very few mastered it really in algebra. How do we do that? Well, again, what's the root? The root is what power? A half. That helps. Let's do that first. So the root's a half. Okay. And now what? Yeah, remember the rules, subtract the powers, right? Now, a lot of people are kind of fuzzy on, like, do you start with the top? Do you start with the bottom? Does it matter? How's that all work? Are you really crystal clear on that? How do you, when you subtract the powers, so it's x to the half over x to the 6th, right? And you know the rule. Like, if you had x to the 10th over x to the 7th, I think you all would know that's x to the 3rd with no problem, right? You'd subtract 10 minus 7 and get 3. Everybody knows that, I think. But what if, let me ask you this. This is where things start to get fuzzy for people. What if the bigger one was on the bottom?
Doesn't matter.
Is it still just x to the 3rd?
No.
Is it negative 3?
Yeah. No.
Or do you just, or is it 1 over x to the 3rd? Do you just say, hey, bigger one's on the bottom, it's on the bottom? Or do you just make it negative? You want me to ask you 4 or 5 more questions you're not sure about? Is this helping? The answer is either one. Those are the same thing. Those are both right. Do you see that? This is the same as this. Remember, negative powers are flipped? It's either way. So the moral of the story is start wherever you want. Start with the top, start with the bottom, start wherever you want. But wherever you start, that's where the answer is going to be. Were you crystal clear on that coming out of algebra? When you subtract powers in a fraction, you can start with the top if you want to, or you can start with the bottom in the subtraction. But whomever you choose to start with, that's where the answer will end up, negative or positive. So in other words, let me try to be really clear on that because it's super important. If you have x to the 7th over x to the 10th, you can say, look, I'm going to start with the bottom. 10 minus 7 is 3. Great. If you do that, your answer goes in the bottom. Or you can say, okay, no, let me do it again. I'm going to start with the top. Okay, you can start with the top if you want. 7 minus 10 is negative 3. But the answer will be where you started. Where did you start? Top. So it'd be x to the negative 3 on the top, which of course is the same. See how those rules are in complete agreement with one another? Start wherever you want, but wherever you start, that's where the answer will end up. Make sense? That crystal clear? So that's the rule from algebra. That's the precise rule. So then coming back to here, I'm just going to start with the top, even though it's smaller, because I just want the answer. I don't want an answer on the bottom, right? So I'm just going to start with the top. And so if I start with the top, then it's going to be a half minus 6. In the top, over 1, but I don't need to show the over 1. It's in the top, because I started with the top. You tracking with me? If you start with the top, the answer's in the top. I started with the half, the top. Now, how do you go a half minus 6, though? Now we have another issue, which you may or may not be crystal clear on from algebra. How do you go a half minus 6? Put it over 1, top and bottom by 2, common denominator, huh? So it's x to the half minus 12 halves, x to the minus 11 halves. There's that minus 11 halves. Everybody see that thing? So let's put it all together. There's so many scribbles everywhere now. Where are we and what are we doing? We're one step away now. So now we see that what we have here is log base 3. This is x to the half over 6 is x to the minus 11 halves we now see. Do you see how all that combination of powers? A half minus 6, a half minus 6 becomes minus 11 halves, and then power comes to the front, right? We know that rule. So the hard part of that one is not the log rules, it's all the algebra power rules. That's what I mean, that it's all about being good at algebra. That's the kind of thing calculus does all the time. The calc rule isn't hard. The log rule wasn't really that hard. It's all the algebra to fuel the new rule. Is that good? Any contend? I'm glad to help you. That's my job here. That's my desire, is to help you with those algebra rules. Is that good? Is that making sense, those power rules? Do you see how we did that? So when you're dividing two x's, you subtract powers. If you start with the top, the answer's in the top. And then the log power just goes to the front, as we know. That's a pretty tricky one. Good? Yeah?
So it wouldn't matter if we put in, say, negative 5.5 over 11.
They said fractions. They want fractions. But it is negative 5.5. You're right. They might take it, but probably not. They said fractions. Yeah. So they want fractions right here. Fractions for any numbers in the expression.
It also says integers, so 5.5
Yeah, 5.5 is not an integer. Integers are whole numbers, positive or negative. 5.5 is a decimal. Yeah. So yes, when they say fractions, they mean no decimals, please. That's what they're saying. A lot. All right, there's a lot of these properties. Let's try this one. All right, rather than me whipping it out, let me let you do that. See what you can do on that one. Combine those single log. Yes, a single log. Make them one. Put those logs together. Make up one big log. We're going to wander around for a minute, see if I can be of help. Better than me just cranking them out real fast. You know if I can help in any way. Feel free to chuck with those around you. You guys are an awfully quiet group. Feel free to compare and contrast. Might get more out of this couple hours we have once a week. I came out of math lecture understanding it about half the time. See if you can do better than that. Good job. Great. All good. Where'd that sit?
Since if you factor the top, you can cancel out x plus 5.
Come up here. Move them up to the tower.
Well, 16 to make one log.
Now, see how this is. 1 of these, 6 of these, they'll cancel 5 up to the bottom.
There's not
Yeah.
But even with the power, what if they said negative 4 logs and then
Oh, yeah, this guy you got
square minus 25 over x plus 5, and then you factor
Yeah, and then you can cancel
x
it
plus
with
5,
x
x
plus 5. Everything else is
minus 5.
good.
You cancel out the x plus 5, x plus 5, x plus 5 by x plus 5, and then you're left by x minus 5. Negative 4 x squared over 25.
Well, that's if you factor it.
Huh?
If you factor it.
Yeah.
Factor it, you can't cancel.
This one can be that.
So that x squared minus 25 factors, right? X plus 5,
You get negative
x plus 5, x minus 5. That's what it is, right?
I still think do I need to cancel?
Oh, yeah, it is.
Oh, okay, so it's
These are dividing now.
Yeah. Right, we're supposed to make it one log this time. Yeah, so we don't want to make it more separate logs, we want to make it one. So really just put these two together into one thing. That's how we change it. Take that 4.
yeah.
So it'll be this log.
Right, but we have to run it back. Yeah, because we're trying to make a single log.
Yeah.
Yeah. So even though this is true, it's totally true. It's just
Yeah, I think it shows the form goes to
Oh, that is 4
the form.
The negative 4.
The negative 4 stays with
No, it's positive. And it becomes positive because now we're dividing. But
I
the
think
negative still goes.
the negative 4, if it stays what it is.
No,
I'm not
you
sure, but I
change it. You change it. Because you're changing. Because this subtracting, that's why you change it to a fraction. Is that minus sign here? Shouldn't that negative go away?
I don't know what that is.
Let me just because of the
easier job for two. Can't be hard, right?
The laws are the same. The negative 4 is
Oh, you can turn it back into exponent.
See how it's
Yeah, I could turn the negative 4 back into exponent. It's not going to be a negative anymore, it's just going to be a positive exponent on 1. So, okay, this is how they did it. So, they were doing cancellations too. So, these two canceled out. And then this was, it was a 7, but then now the exponent's going to be 6. So, that exponent's going to be 3. Because remember, we have to cancel one out. There's one on top. It's going to be 3 now. The exponent's going to be 3. These are canceling one of them out. So, it's missing one of them.
So it will be negative 3 log 4 x minus 5.
The log 4? It'll be 3, not 4 anymore, because remember we canceled them out? Yeah. Because we have to break the x, the squared minus 25 into 2 separate ones. Right. Wait, let me do it real quick.
Are we getting the one that you have over there? Is it the same one, the one you have on the computer over there?
No, it's example, but they're doing the same thing. This is different numbers.
You got a different one on yours? Excellent.
So this is just log 4 and
So it'll be like that. Because remember those two x plus 5, x minus 5? But then this had 4 of them, so we canceled one out. Now the exponent's going to change to a 3.
That's true. It's because he's up in the power, though. See the numbers in the front? Remember, go to the power? Yeah.
That's why it changed to a 3, right? Because we canceled one of them out.
Right. Exactly. Exactly. Yep. Okay, so we're supposed to go to a single log. So if I'm going to go to a single log, it's subtraction. Oh, actually, I should do the power first. The numbers in the front go back to the power, don't they? So that 4 is going to go to his 4th power. And then I will make this x squared minus 25 over x plus 5 to the 4th. Everybody see that first step? I combine the two into one log, right? Subtraction An easy job for 2 logs becomes dividing a harder job for 1 log. Remember the way the properties work? The easier stuff's adding, subtracting. The harder stuff's multiplying, dividing. You get what I mean when I'm saying easier, harder? I'm trying to help you not accidentally do those properties backwards. So, adding, subtracting is easy. That's always for 2 logs. Jobs are easy for 2 logs. Multiplying, dividing is harder. It's always harder for 1 log. Harder job for 1. Right? So, subtracting, easy for 2. Dividing for 1 log. Good there so far? And then the powers, you know that the powers go up here. This 4th power went up here. Okay, now, that numerator can be factored x plus 5, x minus 5. Whoops. Right? When you factor that, we good to there? And then this cancels and leaves 3 of those on the bottom, huh? And that's the answer. Log base 4 of x minus 5 over x plus 5 to the 3rd. Is that making sense? You see how those properties work? Questions on that one? Yeah.
The 3 on the power on the bottom, if you put it like a 1 over the 3 and put that in front of the log, would that be wrong?
That would be wrong. Good question, no. That's a really good question. The reason it would be wrong to put a 1 over 3 in front here of this log, let me write it this way, like that, is because anything that's in front of the log means it could go back and become the power for everything, which it never was the power of the numerator. Do you see the difference? You see what I'm talking? Is that confusing? Everybody see that? Whatever's in front of a log. See what property 3 is saying? It's saying to you, hey, anything you got in front of a log, that thing can become the power of the whole argument. We just called it x here, but this represents everything inside the log. So the problem is, the 1/3 is not the power. There's not a 1/3 on the top and on the bottom. If it was on both, then I could put it in the front, because it would be everybody's power, so it's everybody's multiplier in the front. But it's not. There's just you might say, yeah, but there's a 3 on the bottom and there's a 1 on the top. Yeah, but it's got to be the same thing everywhere, not piece by piece. Because that's what it means to have a power in the front. It's everybody's whole power. Good. Other questions?
Yeah.
On that?
How did x plus 5 and the other x plus 5 cancel?
This and this?
Yeah.
That's just dividing. That just means
okay.
x plus 5, and the bottom is 4 of them.
Okay.
So it's just simply 4 of them. I'm just canceling. Like that, just boom, leaves 3 of them on the bottom. All right, good. All right, so, yeah. What's the best way to do this? Basically, added to 2 logs added becomes 1 log multiplied, right? That's what property 1 says. 2 logs with the easy operation of adding becomes 1 log multiplied. 2 logs subtracted becomes 1 log with dividing, right? And dividing means denominator, doesn't it? So let me just try to say those properties another way to make it more clear. So when I look and I'm looking at, okay, log and another log what? Added, I think, oh, put those together into 1 log with those things times. So that'll become ln of x over x plus 1 times x plus 1 over x. So far, so good? See how the first 2 logs added, that's what property 1's saying, right? 2 logs added becomes 1 log with those arguments multiplied times. So 2 logs added becomes 1 log with those arguments multiplied. And then what about this log subtracted? Means divide, doesn't it? 2 logs subtracted. Now, how do I divide? Well, you could go like this. Don't do this. This would be ugly. I have a better plan. That's true but ugly.
Yeah.
That's true but ugly. That, by the way, that's all in the argument. Right? That's all in 1 log, isn't it? Now, that's true but ugly. What's a easier way to deal with that? Just put it 1 right here. That means divide. 1 over x squared minus 1 means divide by x squared minus 1. Divide means denominator. That's what I'm saying right there. Divide means denominator, doesn't it? For example, if I go 10 divided by 2, isn't that 10 over 2? Right? 5? Right? Doesn't divide mean denominator? Yes, it does. That's exactly what divide means. So when we talk about and log subtracted, that means divide, so just stick it in the denominator. That'd be an easier way to deal with it. Good to there? That's all in one log now, isn't it? Because the adding and the subtracting for the different logs became one log. Divide like that. Okay, now, what can I do with all three of these? Can I clean that up at all? What's this guy here? Can we factor him? X plus 1, x minus 1, and then we'll cancel some stuff, huh? I think. Yeah, a couple things. So then what do we got? Or one thing. So we have x over x minus 1 times x plus 1 over x times 1 over... Now, this x squared minus 1 will become x plus 1, x minus 1. We all good there? That's the factorization of that. And so what does that mean happens from there? Well, this x plus 1 and that x plus 1 cancel. You'll just cross-canceling of fractions. There. And the x with the x, huh? I just noticed that one. So what's left inside of that natural log? Yeah, it's natural log of 1 over x minus 1 squared, isn't it? Oh, they're not going to let me give the answer that way. Hold on, they're going to make me do something more. But that's right. That's true so far. We good so far? We don't need these outer prints, probably a little weird. Good so far? Yeah, now, I want to bring the powers over. Yeah, see what they said here? Powers are supposed to be factors, meaning factor means multiplied things. So those powers are supposed to come to the front, aren't they? So I need to take that 2 and bring him to the front, sorta. But I got to do it correctly, truly, according to the truth. If I just put a 2 in the... in other words, you might think, what's the problem? Just put a 2 in the front. That can't be right. Think with me logically for a minute. That can't be right. Because wouldn't that be, if you had x minus 1 squared, that would be a 2 in the front, wouldn't it? This is 1 over. It's got to be different, doesn't it? Can't be the same as what would happen if there wasn't a 1 over. It's a negative 2. Because it's 2 in the denominator. Amy?
So no matter which way we're going, whether we're trying to make it one denominator or several, there has to be, like, exponents have to be in the front.
No. It's just what they say. They don't always say they have to. This one they did. They said powers as factors. Meaning, don't give me any powers in the end. Give me factors. Whereas the last one, I left the powers, didn't I? Because they never said that line about, see, here's the last problem. They never said make powers factors. Yeah, so it's just if they say so, I got to do it. They're saying make power. That's what I noticed the last time. I was going to stop here. And then I read that line and went, oh, yeah, they're telling me, don't leave your powers. Don't leave your powers. Put them in the front. So the final answer is this 2 goes out of the denominator and goes to the front. Does everybody see that? It's a negative 2, though, because it's from the denominator, isn't it? You're with me? That's still not right, actually. I'm sorry. You know what I'm doing is I'm trying to simplify this, and I'm trying to make it simple, but therefore I'm doing stuff that's not technically true. Let's be really careful here. It's this. That's almost it, but not quite. This is x minus 1 to the negative 2, isn't it? 1 over x minus 2 squared is x minus 1 to the negative 2, right? Negative powers, move it down, make it positive 2 in the denominator, right? Everybody good so far? Then this guy goes to the front. Negative 2 ln of x minus 1. That's correct. Not 1 over. It's not 1 over x minus 1 anymore. It's just normal x minus 1. That's what was incorrect about the way I had left it. Everybody see that? So you really have to make it this way first. You have to be crystal clear from algebra that powers in the denominator are negative powers. and then move that to the front. I'm glad to help you with this stuff. Come by upstairs, see Tim, get extra credit, get help. But you really have to, this is what I had to do too in pre-calculus. I had to just weed out all my misunderstandings of algebra. That's what's going to happen in here for y'all, is you're either going to do that or you're not. And then bad things will happen, at least about your future in math. It's one or the other. You're either going to spend tons of hours raking over these problems going, why the negative? Why the, that's what I did, hours of my life. Why is the, why? And I'd ask my teacher, why the? And he'd go, see, negative. And I go, oh, that's right. And I would slowly learn problem after problem, hour after hour of my life until I learned all these rules. And then really calculus wasn't that bad for me because I went in knowing algebra pretty well. But if you don't, you're going to have trouble. So put the time in, put the hours in, go get the help's available. Get Tim, get me. I'm saying that because here we are in a tense algebra section. Get anything else, but I think graphs are a little more fun, but I guess this is important. All right, I'm starting to do the problem. Yeah, so put that 8 up there. Put those together, same kind of rules. Combine those 3 into 1. Put those 3 together. Those are good questions you're all asking. That's the kind of thing I had to ask my teachers all the time. I'm sure you've got many more that you don't have time to ask. That's why I'm saying go to Tim, me, ask those questions, get those answered. Those are important. Put those things together, crunch them into one log. Yeah, I better help with this. And this one has some more tricks. They have a lot of algebra tricks. So this, that 8's going to go to the power zone, right? Log base 3 of the square root of x minus 1 to the 8th. This is a hard one. This one has a couple of tricks. Oh, yeah, it definitely does. Okay, so we good to there so far? Everybody see what I did? That number in the front goes to the power zone. Good so far? Now, here's our first hurdle. We got several hurdles to get over. What do you do with a square root and an 8th power? How do those two interact together? Yeah, because the square root's a half power, right? Remember we talked about that? We talked about a lot of things. But yeah, good job. That square root is a half. So an 8th power and a square root is a half and an 8, it's 4. Good? First hurdle. We've cleared the first hurdle. That's log base 3 of 8x minus 1 to the 4th, isn't it? Everybody good with that? The square root's a half power. And the 8 and the half of 8, 4. First hurdle's over. That's the 4th. Or I'll just do it right here. Scribble that out, 4. Is that okay, Amy? Good job. Yeah, this is a big 1. That's another hurdle. Good job. Because the high goes high, the top goes top, the bottom goes bottom. That's a 1, isn't it? Good job. Exactly. That's a 1. No, we don't want to do that. Sorry. It's true. It's true, but it's not helpful. It's kind of like me driving home, and as I get close to my house, I said, I'll just circle the block 4 times before I pull the driveway. That's not illegal. The police won't give me a ticket, but it's not the best way to get home, right? So that's what this is. Amy's right. That is 1. But the reason I don't want to do that is because it's not where I'm headed. Where's my goal? I want to put them together. I don't want to separately calculate them. Even though that's true. That's the other hard thing about these is sometimes you're going one way, then you're going the other way, especially on the exam. They're all mixed up, right? So you got to kind of stay focused on your goal, right? Which is hard for me when I drive an autopilot car and I go the wrong way sometimes. So single log, stay where we're going. We're going to one log here, aren't we? We're putting them together. We're not wanting separate calculations. Other times we do, but not here. One log. So instead, I want to crunch these guys together. I don't want to separately calculate them. Okay, well, how do you do that? Well, let's do it. Let's put all 3 together. Remember, when you put 2 or 3 logs together, adding is times, subtraction is divide, right? Subtract this guy. Meaning I'm going to divide that guy. And plus, which means times, that guy. Just him, not the base. We never mess with the base, right? That just stays the same. Log base 3, they're all log base 3, log base 3, log base 3. We don't mess with that. We just take the other parts, and we go 8x minus 1 to the 4th divided by 3 over x times 3. You agree? That's correct. Everybody see what I did there? Right? Because it's subtracting the middle one, so that's divide. Adding the back one, so that's times. And just the argument, not the base. The bases are over here. They're all log base 3. Right? Is that good? So far? Okay. And what do we always do with divide? What do you do when you divide a fraction? Flip it, huh? Flip it. I'm kind of running out of room. We come up here, it's going to be log base 3 of 8x minus 1 to the 4th times x over 3 times 3. Everybody see what happened there? Right? Dividing, flip it. It's upside down multiplying, right? Good. Good. We're close now.
Can we already move the 4 to the front of log?
Good question. No. Good question. You guys have asked about that a couple of times. It's a good question. I hope the answer is sinking in deep. It's a really good question. Can't we just move that 4 to the front? No. Why not?
It wasn't the front earlier, right?
Well, there was an 8, but anyway, why not now? So forget about the past. Why is this not the same as taking that 4 and I thought we could do that. Didn't you say, Mr. Herring? When it's on a thing, you move it to the front. If I put it in the front of the one and only log, the 4, there's only one log here, right? If I put it in the front of the one and only log, we were indicating it used to be the power of everything. If it's in front of everything, it had to be the power of everything. It's not the power of everything. It's only the power part of it. Do you see the problem? Right? That's what this rule says here. It says if you're the power of everybody, then you're the multiplier of everybody. But if you're only the power of some parts, you're not the multiplier of everybody. See the problem? It's a good question. You guys getting that idea? I can't put that 4 there because he's only the power of part of the deal. He's not these guys' power. Right? So he can't be the multiplier for everybody because he was never the power for everybody. Anyway, these 3's just cancel, don't they? Let's just cross cancel and we're done. That's basically it. Log base 3. Just got to keep that 4 where it's at and times it. See how they never said express powers as factors? Because they knew we couldn't. That 4 has to stay where it's at. We can't put that 4 in the front. That's why they didn't say that line that they said right here. See this line here? Express powers as factors. They knew we could. They knew we could. Because in the end, there would just be one thing, and we can move that -2 to the front. But on this one, they know we can't in the end. The 4 must stay put. So they never said that line. You see that? These don't come to the casual, do they? This is Chinese 4 here. Right? This is tough. Amy.
We're not supposed to.
Separate them or something?
No, I'm trying to think of the word. Distribute the X into the.
Oh, no, we don't have to do anything like that. Yeah, on that. Yeah, Rudy. Yeah, it's this right here. Yeah, sorry, I know there's been so many here, there, and everywhere. Huh? Yeah. Yeah, I know. I could do it. That was a mess. Let me do it cleaner. So I don't know if I have time to do this. Oh man, look. So doing it real quick. One more time. 8 power goes up here. So it's 8x minus 1. The half times 8, right? Let me just do one clean swoop. Show you all the deal. Like that. Half of 8 is 4. So that's 8x minus 1 to the 4. Minus means divide by 3 over x. And plus means times 3. Right? And then we go, okay, 8x minus 1 to the 4th. And then times, flip this over, x over 3 times 3 is 3 over 1, cross cancel. Log base 3, 8x minus 1 to the 4th times x. There it is. So I kept showing so many things that aren't true, it got confusing. There's what is true, straight down. Right? Isn't that good? Yeah? Can we do what with it?
Can we fractionize?
Reflection?
Fraction.
Make it a fraction?
Mm-hmm.
Why would we make it a fraction?
Because it has a power of 4. Like we do, x minus 1 and x plus 2, something like that.
Oh, factoring?
Factor.
Factor. Yeah, gotcha. Factor. No, factor is when, see, this is factored. That is factored form. When something is not factored form, it would be like, like that right there. like this. See, this wasn't factored. So factored means written as multiplied. That's what factored means. Timesed together. See how this one wasn't times. We had to make it timesed like that. Right? Whereas this one is. That means 8x minus. Yeah, we don't write it out 4 times. That's what it means, but we don't write it out 4 times. Just leave it like that. We certainly do. The last ones?
No, the graphing ones.
Oh, the graphing ones will be easy? Okay. Good deal. All right, so you can see the answer there. Try that one. Put those together. In fact, I can do that one quick with you. All you do is here, I'll write it out. 3 log base A, 6x to the 8th, minus 1/6, log base A, 7x plus 6. Okay. So we're making it into a single log. Putting it together into one log. So that 3, he goes to the power, doesn't he? Getting the hang of all that stuff. So log base A, whoops. 6x to the 8th to the 3. Is that good? Third power up there? And then, how do you third power this? This means 6x to the 8th, 6x to the 8th, 6x to the 8th, doesn't it? Let me just write it out longhand. Isn't that what that means? And 6 times 6 times 6 in your calculator is 216. Add the powers, x to the 24. Remember that when you multiply x expressions, you multiply the numbers in the front, add the powers? You tracking with me? So 216x to the 4th. So then this is log base A, 216x to the 4th. Now, what is this minus 1/6 going to do? Go to the power. Minus 1/6. Well, what am I doing? Just put the 1/6 up there. It's minus, so that is 7x plus 6 to the 1/6. To the 24th power, huh? 24th power. And there we go. There's the answer. Is that okay on that? Subtraction becomes divide. The 1/6 goes to the power. Like that. Good? So this would be log 2 over log 1/5. Just hit the buttons on your calculator. Right? The top goes top, the bottom goes bottom. Hit the buttons, I'll do it too. 2 divided by... I'm getting negative 0.4306, so negative, what's 3 places? 431. You able to get that? The top goes top, the bottom goes bottom. Just make it 2 logs. Easy enough. Okay, I'll move on. So they're saying we have y equals log base 3 of x. Y equals log base 3 of x. They want us, can you type that into your graphing calculator and graph it? When you type it into your graphing calculator, do you have log base 3? There actually is a special place you could find that. But you could also just say, hey, look, the top goes top. And the bottom goes bottom like that. Just do that rule. Right? You make it into 2 logs. The top goes top, the bottom goes bottom. Type that into your graphing calculator. And they're giving you the viewing window. Negative 2 to 5. Negative 2 to 3. That's x min, x max, y min, y max. And I've already checked the answer. It's B there. Right? See how I typed it into my calculator? Because 1 log becomes 2, right? The top goes top, the bottom goes bottom. Are we good there? All right. I'm going to move on if you're good with that. Okay, so natural log y is natural log 2x plus natural log c. Basically, they want me to solve for y. See how they're saying over here, give me y? They want me to solve for y. So the deal is I need to get this natural log off the y. How do I get that natural log off the y? What's the opposite of natural log? Yeah, powers, right? Remember powers? So again, they're testing that idea. Do we remember? Powers and logs are opposites. What are logs? Inverse powers. So powers and logs are opposites. So if you've got a power you want to get rid of, you put a log. If you've got a log you want to get rid of, you get a power. So I've got a log I want to get rid of. So what am I going to do? I'm going to do a power. So, and what power? The bases have to match. What's the power? E, huh? Oh, actually, you know what? It'd be nice to combine those other two first. You don't have to. But remember, this is 2x times c, isn't it? I'd say I just use property 1. 2 logs added, 1 log times. Right? Harder job for 1 log, multiplying. Easier for 2 adding. Right? Now do the e thing. Now do the e, boom, boom. So y equals 2x times c. Is that good? Is that making sense? So we got y alone, therefore. I just use property 1. Adding of 2 logs becomes multiplying for 1 log, and then just did the e to both sides and got rid of the logs. So we have natural log y is natural log x plus natural log x plus 2 plus natural log c. They want me to solve for y. So can you combine all those logs on the right side? So use property 1. Adding for 3 logs is going to become multiplying for 1 log, isn't it? So this is x times x plus 2 times c. Is that good? For 1 log multiplying, 3 logs added, I just use property 1 again. And now you know what to do. Just do the e thing. E, bye-bye. So y equals x times x plus 2 times c. We got y alone. That's what they're asking for. Get y alone. Equations like this all the time in biology and some of the sciences. That's how you solve for y. Good there. So natural log y is 4x plus natural log c. Okay. So how are we going to... Yeah, this one's a little different, isn't it? Yeah.
Write 4x as a logarithm?
How do we write 4x as a logarithm?
Use e as the base. Or e as the... Use it as a power of e. So ln e to the power of 4x.
ln e to the power of 4x. Yeah, that's tricky. Yeah, I think you can probably make that work. I think it'd be easier to just get the 2 logs on the same side. See how 2 of them are logs, and 1 of them is not. So let me get the logs together, and then I can use log property. See how what's different about this one? You may or may not notice from the last. Look back at the last one. See this one? How everybody was logs. Everybody was logs, right? So just whatever, put them all together, log properties. Trick one here is one of these guys says, I'm not a log. So get the log ones together. Now, what can I do to combine those two? What's subtraction of logs? Division of 1 log. Good so far? Subtraction between two logs is division for one. Good to there? So I would put the log ones together. Like that. And then, how do I get rid of that ln? But you got to do it to both sides. Cancels out here. Y over c is e to the 4x. And we're supposed to get y alone in the end. So what do you do to get y alone? Multiply by that c. So y equals c e to the 4x. See how that got y alone? So I put the two logs together. So you always want all the logs together so you can do the property and then do the e thing on both sides. Is that good?